Good afternoon, everyone, and welcome to today's WorkSafe Tasmania Month webinar, Beyond SunSmart, How Climate Change Will Affect Work Health and Safety. I'm Stephanie from WorkSafe Tasmania and also the coordinator of WorkSafe Tasmania Month. I'll be your moderator for today's webinar. Before we do get started, I would appreciate you taking a few moments, though, to read the following slide about information delivered during WorkSafe Month sessions. So I'll now take a few moments to go over a few items about how you can participate in today's webinar. So we've taken a screenshot of an example of the attendee interface. So you should see something that looks like this on your computer screen in the upper right corner. You're most likely listening in using your computer's speaker system by default. However, if you would prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. You'll also have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You can send your questions in at any time during the presentation. We will collect and address these questions during the webinar and also at the end of today's presentation. We are recording webinars during WorkSafe Tasmania Month and will progressively make these webinars available on the WorkSafe site at the end of WorkSafe Month. Lastly, once you do leave today's webinar, you will receive a survey on the presentation, and we would appreciate you taking a few moments to complete that survey and providing us with your feedback about today's webinar and also your webinar experience. So it is now my pleasure to hand you over to Sharon Campbell from the Tasmanian Department of Health and Human Services to present this afternoon's webinar, Beyond SunSmart, How Climate Change Will Affect Work Health and Safety. Welcome, Sharon.
Thanks, Steph, and thanks to WorkSafe for having the opportunity to present about this topic. And also thanks to everyone who's dialed in or logged in and you're interested in mention health and safety projects or your work health and safety outcomes. As Steph mentioned, I'll give lots of opportunity for questions. So if you have a question at any time, then just type it into Steph and she'll give me a little indication that there's a question there. I actually can't see them, so she'll just let me know and I'll address that straight away. And you've probably got questions at the end as well, so I'm really happy to address those as we go through. So the session's really divided into 4 sections. The first part is really an overview of climate change, what we already know given the science and the research that's happening all around the world. And then we narrow it down to how will climate change affect Tasmania. And then we narrow it right down again to how climate change and work health and safety interact between each other. And then the obvious question of what you can do, and that's probably why you're really here, is to find out what you can do to take back to your workplace. So let's kick off and talk about what we know for climate change. So in September 2013, it actually sounds like a little while ago now, but it's not that long ago, the Intergovernmental Panel on Climate Change Working Group released their report number 5. Now that working group is pretty extraordinary in the terms of science. There's no other scientific sector or research area that has a equivalent of the IPCC. So it's about 2,000 researchers from all around the world, from all different areas of climate change, and they come together into a forum every 5 years and they discuss every single line of the report that is released, and everybody has to agree on all of those. And so it's, as I said, it's really an unprecedented aspect of climate change research. If you can imagine 2,000 dietitians, for example, agreeing on a healthy diet, then you've kind of got the idea of how much work it takes to get that many people from a large, diverse group to agree on one thing. So in terms of policy, we feel really confident that, you know, the IPCC outcomes are very genuine and very research-based. So as I said, every 5 years they do a report. The most recent one was in 2013. And what they came out with was the major finding was that the Earth's climate is warming, both the atmosphere and the oceans. And that wasn't necessarily a surprise. And to put it in context, that's been one of the major report findings right from report one. And the reason they've changed on the way, one of the parts that have changed on the way through is the certainty of that statement. The second major finding is that there'd be an increase in climate variability into the future. So that means that we'll have more extremes, and we'll talk about this in a minute. Thirdly, that there's widespread and major repercussions for everybody and all around the globe. But they're not necessarily given that everyone will experience those equally. Typically, when there's an extreme weather event, for example, it's the poorest and the most disadvantaged among any group that's experiencing that will have the worst outcomes. And finally, here we go. Finally, their other major outcome is that human influence is the dominant cause of this changing climate, and we know that now with 95% certainty. And this really, the fourth point, is the one that's changed a lot all the way through. So if we go back to report 1 or 2, we'll see that it's possible, and then as we go through it becomes likely. And now we know with 95% certainty that it's the dominant cause. It's a great little graph that I'll show here, and hopefully you can see that, we'll see those colours well on your screen. So what we're looking here is the actual observations of land and ocean temperature and how it's increased, and you can see probably from about 1970 it started to go up fairly steeply. And that black line shows that observation. Now, there are things out in the world that can cause changes in temperatures, so they're things like solar cycles, for example. So radiation from the sun actually changes on quite a regular cycle. Things like volcanoes actually have quite a big impact. So when they spew ash into the atmosphere, that actually causes a cooling. And there's lots of other geographical and geophysical forces there. So when we map all of those, what we call natural forcings, onto a model that would predict how temperature would change, what we get is that blue bar that is pretty flat right across the bottom there. And then when we also add in what's called the anthropogenic forcings, or the human influence forcings or factors that cause changes in temperature, what we end up with is a model that actually tracks pretty much exactly what we're seeing happening in the real world. So we know the difference between the natural forcings and the human-induced forcings are the things that are causing that difference. As I said, if you've got any questions, just type them in as we go through, and Steph will give me a hoy to answer those. So what else do we know? Well, I guess it's a pretty obvious statement here, but we're able to measure what has happened in the past with a great deal of accuracy, and we do that through, you know, observations, but we also do that through things like ice cores, and, you know, we can work out how much carbon dioxide was in the atmosphere from a particular period in time, even going back quite a long way, through ice cores, and from there we can extrapolate things like temperature. But we can't do that into the future, although it is Back to the Future Day, I believe. So I'm sure I can tie that in somehow. But generally, we can't model that behaviour into the future. So what really is the key here is the accuracy of this future model is dependent on future action. So in other words, we can model it into the future. We can't necessarily say this is exactly what's going to happen. but we can model that. But how accurate that modelling is depends on what we do at the same time, and even what we do right now. So, and that thing can obviously change. So climate modellers use what's called different emission scenarios that reflect different types of future actions. So for example, if we keep going down the path that we're going, then that's called an A1 to A2 an emission scenario. If we tighten our belts in terms of climate emissions, then that's called a B1 and B2 scenario. And I'll give you a little graph here that shows, sorry, these graphs are taking a little while to pop up. So what we've got here is the black line that finishes just after 2000, so probably about 2008, I guess. That's actually the Bureau of Meteorology observed temperature changes. What we've got after that in periods 2, 3 and 4 is the expected or predicted mean temperature changes based on those two different types of emission scenarios. So the red ones is actually A2. So what we can say is basically if we keep going down exactly the way we are, then we're going to end up with much larger increases in mean temperature all the way out to the end of this century. If we start to tighten up how much emissions we're putting out, for example, things like reducing the amount of car usage that we have or reducing coal consumption, then we're still pretty much bound to have a rise, but it won't be anywhere near as drastic as it would be. So that's why sometimes there can be a little bit of confusion in the world about, the future of climate change, and it's only because it's really dependent on what we do right now to the accuracy of those models. And the way you can remember this is B1 and B2 are cool. So if you employ a B1 or B2 scenario, then we'll stay cool. So this is another way of kind of looking at the same thing. So the left-hand side of the graph is a model that is how it would go if we adopted a B1 or B2 likely scenario. The right-hand side is a model of how the world's temperatures will change if we go on a path of the same thing that we're doing right now, I guess. So you can see that there'll still, no matter what we do, there'll still be some warming across the northern hemisphere, and we know that that's having an impact in the Arctic already. But if you look at the right-hand side, you'll see that there's a huge degree of warming right across the northern hemisphere and then moving down through the southern hemisphere. If you have a look at Tassie, one of the least affected areas, but that's not to say that Tassie won't necessarily feel the repercussions of the other areas in the world that are warming. Which is a good time to talk about Tassie. But just before we do that, has anyone got any questions on some of those general concepts that we talked about, what we know about climate change?
So if you do want to submit any questions at any time during the presentation, again, if you type those questions into the question pane of the control panel.
No worries. All right, I'm going to keep going, but if you get any, just stop me and I'll answer those. So that's, in a really big picture, that's what's happening in terms of global impact, and obviously I could go into any one of those issues in a lot more detail. But let's talk about now climate change in Tasmania, and we've been really lucky to have a project that was sponsored a couple of years ago called Climate Futures Tasmania, and that brought a lot of climate modellers together and really went and drilled down into some of these issues, looking at some of those emission scenarios and how those would impact directly on Tasmania. And there were 4 things that they really discovered here. Oh, here we go. No, we don't. Hang on. Here we go. Okay, not sure why that took quite a few clicks, but hopefully that's not going to happen again. Okay, so the first thing is that the number of warmer summer days and nights is projected to increase by about 2 to 3 times. So in other words, we're going to have more hot weather or more hots. Secondly, heat waves are projected to occur more frequently. So not only is it going to get hotter, but it's going to happen more often. So we're going to have those 4 times by the end of the century. So it's more hots and it's hotter hots. Thirdly, we're going to get what's called less normal rainfall patterns. So that's those extremes that we're talking about. So when it does rain, it's going to rain a lot more, but when we don't have rain, that's going to be for a longer and more intense period of time. So we're going to have wetter wets and drier dries. Now, if you forget anything about the rest of this presentation, and I really hope you don't, I would love you to remember those 4 things of the future of climate change in Tasmania. More hots, hotter hots, wetter wets, and drier dries. So you can try and work that into your next barbecue conversation that you have maybe tomorrow when you're having a day off. And so to look at that graphically, this is what it looks like. And sorry, these pictures are a little bit squished. So in general, cold waves are going to happen less often. So we know that the centre of Tassie is generally the coldest. In the middle of winter, we always look at Lyowini and it says it's -7 or something like that. That's going to happen less and less and less. So the map of Tasmania on the left-hand side there shows the mean number of cold wave events in that 40-year period between 1961 and 1990. Sorry, 30-year period. On the right-hand side, you'll see the same number of cold wave events in the period from 2070 to the end of the century, and that's happening almost, not really any time at all. So that's the first thing, cold waves are going to happen far less. The flip side of that is that heat waves will happen more often. So at the moment, generally when we do get a heat wave, the first place it hits is through the Midlands, so Campbelltown, Ouse, Ross, those sort of places. They're the longest distance from the coast. It's flat, it's exposed. They're also quite cold, of course, in winter, but they do tend to heat up quite a lot in summer. Moving forward towards 2070 and onwards, then we're starting to see those heatwave events in those areas get quite excessive, but you can start to see how it spreads all the way through, right across Tasmania, even onto the west coast, and that's something that is alarming, I guess, for some of the industries on the west coast. Now, this looks like it's happening a long way into the future. So if you look at 2070, you go, well, I don't really care, I won't be here. But the point being that these are modelled on particular scenarios based on actions that happen right now. So these events could well take place much sooner because of the events that are happening in the world right now. The extreme rainfall events. So these graphs are a little bit tricky to understand, but if on the left-hand side, these are the maps for the very wet days, so there's really high rainfall days. That's a map of where they occur in the 95th percentile of occurrences in Tasmania. So you can see, as you would expect, that the vast majority happen on the west coast and the east coast is relatively dry. Move forward a few years, or 50 years, and you'll see that that pattern has changed quite dramatically. So we see a little bit of rain on the west and the south coast, barely any through the centre, and some really dry areas up through the Midlands area, and that of course is where we grow a lot of crops. And then surprisingly, some actually quite wet areas on the east coast as well, so the southeast and the northeast and Flinders Island. So there's some really big shifts in the way that rainfall events will occur in those areas, and that obviously has a really big impact on agriculture. So pulling all of that together, what does it actually mean? So we've got some big impacts on the health sector, and that's really what we're going to talk about. We've got some massive impacts on the agricultural sector and the water catchment, and given the way that we generate energy in Tassie, then the water catchment is a big issue. There's also some massive issues around emergency management in terms of extreme events and local government impacts, and especially some of the coastal areas, so coastal inundation. And if you want to know more about that, then there's a website at the bottom there for the Climate Futures Tasmania reports. And if you're interested in that, then there's some fabulous information in there, and it's really quite straightforward and easy to digest. And I should have said earlier that after this presentation, Steph will be emailing this out to you, so you'll be able to get a copy of that website. If you're madly writing it down right now, you don't need to. Any questions about some of that impact on Tasmania? Okay. So let's have a look then around how climate change and work health and safety actually link together. So at the moment, you're probably starting to see the tip of the iceberg about how they might link together, or you've probably already know some of that stuff, and that's why you've turned up here to start with. So there are quite direct effects. The first one of these is the physical impact of extreme weather events. So if we're going to get more heat waves, for example, then there's a physical impact of that. If we're going to get more rainfall, there's a physical impact of that. Bushfires flow on from heat, floods flow on from extreme rainfall events. And, you know, we all know the media looks at some of these issues and portrays them in a very emotional way. So you think of bushfires and you think of floods and storms and so on, of houses washing down rivers, of, you know, things blowing up and burning. It's quite extreme, it's very emotive. Heat isn't really so much like that, and that's, you know, it doesn't make great media coverage for people to be filmed while they're dying alone in their home, unfortunately, because otherwise there'd be a lot more attention to the impact of heat. But the reality for Australia is that heat as a natural disaster actually kills more people than all other natural disasters combined. So if you think of all the people killed in Australia in the last 150 years from floods, from bushfires, from storms, from cyclones, they all are way down the list when compared to the people in Australia that have been killed through heat illness. So about 55% of all the people killed in natural disasters in Australia in the last 150 years have been through heat. And I think bushfires come second, and it kicks in around 14% or something like that. So it's quite an extreme difference there. The second direct impact of climate change, as we're starting to think around work health and safety, is the air quality and respiratory illness. So if you have heat, then you have poorer air quality, and the same goes for bushfires. And that, of course, leads to acute and chronic respiratory illness, but we're going to talk about that a little bit more. The third direct effect is what's called vector-borne diseases. And when I say vector-borne, I'm usually talking about mosquitoes. So mosquitoes have an affinity for warm weather. So the more warm weather that we have, the more mosquitoes there are. And the diseases that they'll transmit, including malaria and dengue, there's lots of other really obscure ones as well, but together they add up to quite a large impact on the health system. So we've got lots of research that's been showing that, for example, as the climate has warmed in Africa, then malaria-carrying mosquitoes are starting to change where they habitate sort of further up in altitude and also across wider areas, and they're taking that malaria with them. And we get the same impact with dengue as well. These issues, obviously not so big for Tassie, but we'll start to see endemic malaria and dengue moving into more northern parts of Australia, and you know, we might see dengue come down to Brisbane or to Sydney. We're a very mobile population, so there's no reason why you couldn't in the future fly to Brisbane for a holiday, get infected with dengue, but then the impact will be felt on the Tasmanian health system. So that's the sort of thing that we need to look at in Tasmania as well, even though it's highly unlikely that those particular mosquitoes will ever make their way and be endemic in Tassie. Fourthly, the direct impact on food and water security is quite extreme. So if, for example, you think of a flood event, then you've got the irony of having lots and lots of water around and no drinkable water. There might be extreme heat events that kill off large crops, and so you've got food and water security issues like that. Now, there's lots of other indirect impacts as well. I don't really have time to go into a lot of those, but really we're here to talk about two things. One of those is heat and one of those is air quality. And so that's what we're talking about when we're talking about the link between work health and safety and climate change. Now, this next diagram, it's quite complex, and you'll get this diagram through that Journal of Occupational and Environmental Health Hygiene paper, and I'll send that out, or Steph will send that out with the presentation at the end as well. So again, don't feel like you need to write all of these bits and pieces down. But this is really interesting because this is basically a framework for how climate change can impact occupational health. So if we go from the top, you can see that there's lots of things that impact on global climate change: population growth, energy policies, local conditions and circumstances, and then some of the other bigger ticket items like urbanisation or deforestation. And all of those contribute to some of the hazards and exposures. We've talked about a couple of those already. And then all of those impact on occupational health impacts. Now, of all of that diagram, we're only going to be talking about this little bit today. So you can see that we've really cherry-picked, if you like, some of the stuff, but there's really a lot more work to be looking at to make a complete, what we call it, like a complete picture of the impact of climate change on occupational health and safety. Okay, so let's talk about heat and air quality. So heat in Australia, more people have died as a result of extreme heat events than all other natural disasters combined, and that's what I was mentioning earlier. I got a bit ahead of myself. If you want to download that paper, it's a really, really interesting paper to read. But again, you'll get that when you get your presentation notes at the end. And that's usually a pretty big statistic for people to take in, and they often don't believe it. But it's not just a little bit more, it's a lot more. And heat is invisible. So all of the natural disasters create some of those media images, some of those emotive things that we've talked about, but heat doesn't. The people that are impacted by heat are generally not as media, they're not as present in the media, let's say. Okay, now heat discriminates. So when you have, if we say a bushfire, for example, then it doesn't really go, I won't burn that house down, I will burn that house down, I won't burn that one down because there's nice people live over there, and so on and so forth. It just takes out everything in its path. It does sometimes seem to be that it discriminates between one house and another, but generally that seems to be because of the materials the house was built in, for example, not because of the residents or anything else too magical. The thing about heat is it doesn't do that. It actually discriminates and has quite specific target groups. And the reasons for that are complex. They're physiological, they're social. So if we look at the elderly and the frail, then physiologically they have less adaptation to heat. So they can't thermoregulate, they can't adjust their body temperature as easily as someone younger. So when we look at the statistics of who dies in an extreme heat event, the elderly, usually people, when I say elderly, I usually mean people over 65, they are much higher represented in the statistics than anybody else. The other group that's highly discriminated against in a heat event is those from a low socioeconomic population. And there's a complex set of reasons for that. So if, say, for example, you are relatively poor, you may not have an air conditioner in your home. It's likely that your home won't be as well insulated, so the impact of heat in your home is much higher. Even if you're lucky enough to have an air conditioner, you're probably reluctant to turn it on because it costs money. You're less able to be able to get yourself to somewhere cooler, so just the impact of getting in your car and driving to the shopping centre and sitting in the shopping centre all day, well, you may not have a car to be able to do that with, or the cost of actually catching the public transport might be too high, or you actually live a long way from public transport and you don't feel comfortable walking out in the heat to the nearest bus stop to be able to do that. So it's a really complex set of circumstances. In addition, people with existing chronic health conditions are also impacted. So anyone with diabetes, with cardiovascular disease, with kidney problems, anyone with mental health issues, anyone, all of those people find it much, much more difficult to cope with heat. And what about the people that you guys are really interested in? I'm not saying that you're not interested in elderly, frail and low socioeconomic people, but the reason you're here is you want to hear about the outdoor workforce. So anyone who's working outdoors is obviously going to be much more impacted by heat than those working indoors, even if there's no air conditioning. So those people from a maintenance sector, in mining, in farm work, in firefighting and any other emergency services are again overrepresented when we look at statistics for people that have died in heat emergencies. And those two papers that I've put there that I've referenced this from, the Hannah one is really interesting. You'll get that as part of your notes as well. And the one from Peng Bai is also great. There's Peng Bai has actually done quite a lot of stuff on extreme heat and morbidity in Australia. He's a researcher from Adelaide University. And this is a really good overview of some of the things that we are talking about here. So I would encourage you to go and read both of those papers. That little red line is actually supposed to be over the outdoor workers area, so that's just when we stretched out the presentation to fit the screen, it didn't work quite so well. Anyway, not true, but that red line is really just saying that's what we want to focus on from this point forward and look at who are outdoor workers and how they're being impacted. Okay. Now, what you might find quite surprising is that heat-related deaths of outdoor workers occur at what we would consider, even in Tasmania, as relatively low temperatures. One of the documents that you'll get is from the Centres for Disease Control and Prevention, and it's called the Morbidity and Mortality Weekly Report. And this report came out in 2014, so last year. And it was a report on heat illness and death among workers in the United States. And it actually gives a little breakdown of some of the individual events. And as I was going through this table, it really struck me that some of the temperatures and some of the fatalities didn't really seem to match up, but yet they actually happened. So again, you'll get a copy of this as part of your little pack to take away. But let me just have a quick skip through here and we'll see. That's what I wanted to point out. Okay, so here we go. So there was a 60-year-old man who died. He was in the roofing industry. He died when the temperature at the time was less than 30 degrees. It was about 29 degrees. He had scheduled breaks. The employer did provide some shaded area for that person to take some respite in. But there was other things that they didn't have in place. They didn't have an acclimatisation program, and there wasn't an overall policy around heat and heat health in the organisation. Because he was working on the roof and it had the reflective, so he wasn't just getting the sun beating down from the top, he was also getting the reflective roof surface exposure from underneath. And he was wearing black clothing, which, as we know, absorbs higher temperatures. So this unfortunate fellow at 60 years old passed away from a heat illness by doing his job, and it clearly could have been quite highly prevented, but in a temperature where you wouldn't really expect it. In this table, in this document, there's lots of those sorts of examples. We have another 36-year-old person, I don't know whether that's male or female, they died working outdoors laying some pipe work in a temperature of 31 degrees. They had scheduled breaks, but again didn't have some of the other policies in place. Yeah, so this table reads as a little bit of a sobering issues, if you like, of deaths and illnesses in temperatures, as I said, that you wouldn't really expect to have caused those fatalities. But because there were these extraneous conditions that caused them, then that's a big contributing factor. It's not just that people die and become very sick, the work capacity and productivity reduces quite rapidly at hot temperatures as well. So you're just not getting the most out of your workers in terms of productivity when the temperature starts to climb. In terms of what actually happens to workers when the temperature starts to climb, generally you get higher injury claims on hotter days. So for outdoor industries, your total workers' compensation claims are likely to increase by 6% or more. The target group for those are male labourers and tradesperson over 55. So again, it's typically going to be people that are elderly, and in a lot of outdoor workers that demographic is going to be generally more male. It's those employed in agriculture, forestry and fishing, and electricity, gas and water sectors that are most likely to be overrepresented. And if I could ask you, I'd say what types of injuries would you expect? And you'd probably expect things like heat illness or fainting or things like that. And that's one of them, but it's not all of them. So they're more likely to report burns, wounds, lacerations, and injuries as a result of moving objects. And that comes down to what I spoke about earlier, is really that work capacity and productivity isn't there on a hot day as it would be on a cooler day. So you're more distracted by the heat, you're more likely to do something a little bit silly. Now this is Australian data that we're talking about here, so this is not something that happens only in Finland when it reaches 25 degrees. This happens in Australia. So what you've also got to remember is, yes, this research was done in South Australia, but in the temperatures they're talking about there will probably be higher than we would experience in Tassie, but in Tasmania we don't have the ability to acclimatise quite as quickly. So as we've been seeing for these last few days, we've had some really extreme leaps and lows in temperature, but that's actually fairly normal for us. So we don't have the chance to acclimatise through a summer as it might be in on the mainland. And that actually means that when we do get an extremely hot day, then we're actually more likely to feel those impacts. So that's the heat side of it. What about the air quality side? So we get an increase in what's called particulate matter, which is usually smoke matter or air pollution, and also something called ground level ozone when it's warmer. And those two things aren't great for us. So we get a reduction in lung function, so it's just a lot harder to breathe. For some people, a lot harder than others. So those who already have asthma find it much, much harder to breathe. There can be an aggravation of heart disease. So it's actually that really fine particulate matter that happens as a result of bushfires. Then that actually has an impact on our coronary arteries and leads to an increase or an aggravation of heart disease. Now there's short-term and long-term exposure risk. So if you have an extremely hot day and a bushfire as a result of that, or even not even a bushfire, just an extremely hot day, and you get that increase in ground level ozone, then that has a really short-term effect, and you might find it's not that comfortable to breathe, or you're having trouble breathing in that particular day. But there's also long-term effects and long-term impacts on our cardiovascular system and our respiratory system. I think I've jumped ahead of myself a little bit again and talked about that. Yeah, so ground level ozone increases with heat, as I've mentioned, and the particulate matter increases with bushfires, which are way more likely to happen on hot days. And again, our outdoor workers, because they're most exposed, are the most at risk from these issues. Has anyone got any questions at this point? I've thrown a huge amount of information at you, and you're probably sitting there digesting a little bit, but just before we move on to the next bit about what you can do, I just want to make sure that you've got this kind of sunk down and embedded. And I can take a drink of water. Okay.
You're pretty right to go on, Sharon.
Good to go. Excellent. Okay, so this is probably the most important bit really, is what you can actually do. So in terms of actively being able to impact this in your workplace, one of the most critical things is that you develop a heat policy or a heat illness prevention program for outdoor workers. And these can be some really basic things. So do I have areas of cool, shady spots readily available? Have I written in some sort of rest program or respite system into my policy, my workday? Do I have cool water available? Can my employees work flexible hours? Is it possible that they could work more in the morning and out of the heat of the day? Does my workplace have an awareness of some of the public health warnings that are out there for heatwave events? So, for example, where I work in public health services, we have a heatwave alert system, and when we know that there's a forecast hot day coming up that's sort of out of the ordinary, then we will start to issue warnings. One of the ways that you can pick up on those warnings is through our Twitter account, which has the handle of Pop Health, POPHEALTH. So if you subscribe to that Twitter account, then you'll get a little warning about the hot weather. But of course we also do much bigger media coverage as well, so you'll start to see media coverage around the fact it's going to be extreme temperatures coming up. And the big question that you guys need to go away and think about is, what else can you do? Because there's going to be, each individual workplace has its own anomalies, if you like, of what you can actually do to impact the amount of heat illness and air quality illness that's felt by your employees. So in terms of what you can think about when you go back to your workplace, does your workplace actually have a working in heat policy or a heat illness prevention program? I'm guessing that if you've tuned into this, then it's likely that you don't, but it's possible that you think you should have. One of the questions to ask when you're doing that investigation is really, has heat already affected your work productivity or your workflow? And the only way you're really going to know that is by asking your employees. And then coming out of that, what are some of the strategies that might work in your workplace to reduce the impact of heat illness on some of those extreme days? There is a little bit of a cultural thing, I think, in Australia around, well, it's just a hot day, just man up and get on with it. Part of that, by implementing a policy or a illness prevention program, is we can start to break that culture down a little bit, so that if there is an idea that people are feeling the heat and feeling quite disturbed or upset, or feeling a bit faint or a bit dizzy, then they're well within their rights to go and sit down in a cool shady spot, have a drink of water and have a rest, and decide if they need to keep going at that point or if it's too hot for them, because their life is actually at risk at this point. Okay, one of the other things that you can do, which is a little bit not so direct, if you like, is to be involved in research into outdoor workers and the effect of heat. So there's a couple of questions that research might look at. One is, how does exposure to heat and humidity affect people's health and their ability to continue physical work or activity on a hot day? And the second question is, what is the range of heat tolerance across Australia in the workforce? given our diverse climatic conditions and workplace settings. Now, there is actually a research study going on at the moment through ANU that's looking at that. They're always looking for further work sites, so if you are interested in having your work site being part of this research, then you can go to that website, or you can contact me and I can put you in touch with those researchers as well. There are a few Tasmanian sites that are part of this research. There's not a big impact on your working life. You're just asking the workers to keep a short diary, and they'll also have a little temperature gauge that we set up at your workplace. So there's really very, very little impact, and you will be then contributing to a much bigger research project about how productivity is impacted by heat in Australia. So I'll just finish off by doing a case study on a group that has looked at climate change as a bigger picture and tried to address some of the issues around climate change and how it's been impacting them. So we're not talking about just heat at the moment, but we're talking about some other issues. And I'm sure you've all heard of Pennicott Wilderness Journeys, so run by Rob Pennicott, who operates down out of Brenny and does, down near Port Arthur, and has tours around that peninsula area, and has won lots and lots of awards for his experiences and his trips. So as a group, they actually looked at what was happening for their workplace and how climate change was impacting them and what they could do. So as I said, they provide wilderness tours around the Bruny Island and Tasman Peninsula area. When this case study was written, they had 6 boats, about 70 staff, but I believe that's increased quite a bit. They are the recipients of quite a few tourism awards, both state and nationally. They have a big commitment to local environment and economic stability, and they're one of the major employers in that area. One of the things that they do is offset their carbon emissions by 100%, which is brilliant given the fact that they run boats and buses and that sort of thing. And 25% of their profits are given back to local projects. So, they really are a great example of what you can do in your local environment. So they had a look and identified some of their threats and some of their opportunities given the research around climate change. One of the things they identified was, as an opportunity, was increased temperatures actually increases bookings. So that's a great thing for them. So it gets warmer in Tassie, more people are likely to come here, and that increases their bookings, so that's great. However, heavier rainfall actually decreases their bookings. So if they're getting more extreme rainfall events, then just from a safety point of view, they can't go out, but it's highly likely that people won't book because of the weather. High wind is also an issue for Tassie, as we found out over the last few weeks, and that can cause some major safety issues for people on boats, for example. So, again, those more extreme windy days, and if there's more likely to be more extreme windy days, then that can decrease their the number of trips that they can run as well. Bushfires in the area did have a big impact on them back in 2013. Of course, it limits the amount that they can take out, but also limits how many customers can actually get there, and obviously that whole area was impacted quite significantly from a tourism point of view. And lastly, when we look at the research around sea level rise, it can have an impact on how customers can get to the jetty and how they can refuel, so just some logistical issues there. In terms of what they wanted to do and how they could get around some of that, they looked at how they could adapt to some of these issues. One of the ways they looked at was they can have more than one location. So if they have one location, something goes wrong at that particular location, they're very stuck, but if they have different locations all around the peninsula that they can draw on and work with, then their impact reduces quite significantly. They had a significant look at their site and assets, so how does sea level and the water supply actually, how does sea level changes and water supply, for example, impact where they build their sites and how they build their sites. Pennicott were quite influential in providing disaster support to those people that were isolated in the January 2013 fires down in that region. So obviously they abandoned their tours and used all of their boats to actually start to evacuate people. And I think without that, there would have been a much bigger impact on the emergency services. And one of the things that they do quite strongly is when they do their when they do their tours, they talk about climate change and the impact on the areas. So they consider community education as a big part of their role in that to the tourists and their customers. There's lots of other case studies for other businesses in Tasmania on how they've addressed climate change, and if you go to the Tasmanian Climate Change Office website or just search for Tasmanian Climate Change Office, and you'll see that they've got a little link on case studies, and I would highly encourage you to peruse some of those other case studies to see how Tasmanian organisations have adapted to some of those challenges and opportunities that we've discussed. So that's it from me. There's my details if you want to get in touch and discuss this more. The website at the bottom is the Public Health Extreme Heat information page, and on that page there's a lot of resources. We've got a brochure that you can download and distribute that's just for individual use. We've got a 40-page guide on how to, small 40 pages, it's okay, on how to prepare and cope for in extreme heat events. And there's also quite a few fact sheets specifically on issues associated with extreme heat, like how do I sleep better in extreme heat, what do I do if I'm pregnant, what about young children, that sort of thing. So I would encourage you to have a look at that in advance as well. And is there any questions? Thanks so much for listening, for taking time out of your afternoon and listening, first of all, and really encourage any questions in the last, what have we got, 8 minutes that we've got.
All right, thank you very much, Sharon. And yeah, we certainly do thank you for running your webinar this afternoon, Beyond SunSmart, How Climate Change Will Affect Work Health and Safety. As Sharon said, we've still got some time during the webinar, so if anyone does have any questions, please do submit those questions to the questions pane in the attendee control panel. While any final questions are coming through, just a reminder that WorkSafe Tasmania Month runs until next Friday, so do head to the WorkSafe Tas website, have a look at our program of events, look at the other webinars that we are running up until sorry, next Friday, and we are running venue sessions in Devonport and Smithton next week. So again, do head to the WorkSafe site for any further activities that we are running.
Just while I'm waiting for some questions there, as I said a few times, Steph will send out to attendees a little information pack, so that'll include the presentation as you just saw, some of the other papers that are referred to, and also a document from WorkSafe Tasmania called Working in Heat, and that just helps you outline, you know, similar to what I was talking about here, but also gives you some other resources to work from as well.
All right, thank you, Sharon. Look, as no questions have come in, I'll do a wrap up. So thank you very much, Sharon, for joining us this afternoon to present this afternoon's webinar. Thank you as well to everyone who did hook into today's presentation as well. Again, if you do have any further questions, Sharon's contact details, if you didn't get a chance to write them down, will be in the information that we send out following the webinar. And again, once you do leave today's presentation, you will have a survey, so we do appreciate you taking a few moments to complete that and providing us with your feedback. So on behalf of WorkSafe Tasmania and our presenter Sharon Campbell from the Tasmanian Department of Health and Human Services, thank you for joining us today and have a great, safe and healthy rest of the day. Thank you, Sharon.
Lovely. Thanks so much, Steph, and thanks to everyone. Bye now.